This is a lecture for Chapter 7 for Math 107 on sigma notation. This is the Greek capital letter sigma. Lowercase sigma looks like this. Doesn't look anything like the uppercase sigma, but this is Greek letter sigma, and it stands for sum. Here's your S here, or addition. And this is how it's used. It will have a subscript with a counter, and it gives the start for the counter. In this case, the counter starts at 0, and the maximum value of the counter. After it, you have this term that's called the formula. So this is what we're talking about here. The subscript on the sigma is the starting point, starting value. The superscript is the maximum or final value. The term or terms after the sigma, that's called the formula. So how you use this is this formula usually has a counter in it. In this case, it's k. Could be in, could be m, whatever. You just look and figure out what it is. Then you start the counter at its starting value 0. So you put 0 into the formula and get your first term. So here's the first term, 0 squared, because it's k squared. Advance the counter by 1, so the k goes from 0 to 1. Put that in your formula. And because sigma stands for sum, you add them. So there's your plus sign. Advance the counter again, 2 squared. Advance the counter again to 3, 3 squared. You're all the time adding. Advance the counter again to 4, 4 squared. When I advance it to 5, I do 5 squared, and that's my last number that I use. This is their maximum right here. And then, of course, you just go and do your arithmetic after that. So remember, the factorials had to do with multiplication. The sigma has to do with addition. Now, the operation for using sigma is not too difficult. I hope if you have any questions, of course, contact me about it. But there are some rules that I want you to know about using the sigma notation, and they actually make things easier. Here again is my sigma, and I've got the starting value of 1. The ending value in this case again is 5. The formula afterwards is 15 times n. So I start with a counter n equal 1. So I put 1 into the formula. I forgot the pin right here. I make n be 1 because that's a start, and that gives me my first term, 15 times 1. Now advance the counter to 2, and I get 15 times 2, and adding as we go, and add again, advancing the counter to 3, advance the counter to 4, and well, look at that. Okay, we'll fix that here. Change that to 4. Okay, now we're going from 1 to 4. Obviously, I forgot the fifth term. Let me explain again what I was doing. I start the counter at 1. I end now correctly at 4. So when the counter n equals 1, I put 1 into the formula. That gives me my first term. Then I add the second term. Second term n has been advanced to 2. So here's 15 times 2, 15 times 3, 15 times 4. Now look at this arithmetic. The 15 could be factored out. That would just leave me with 15 times 1 plus 2 plus 3 plus 4. Well, 1 plus 2 plus 3 plus 4 could be written in sigma notation. And the 15 is now on the outside, multiplying the result of this addition. What it looks like, I just showed you how I got there with these intervening steps. But the idea here is that if I have some constant like 395 times k, and k is going from 16 to 924, I can factor out the 395 and just do the sum and then multiply that in by itself. Now it saves 924, whatever I wrote up here, and now you're just having the k. So constants can come out in front. That's what this rule is all about. Now, of course, it's easier, and as I've impressed upon you in this class, I hope, the fewer things you do, the fewer mistakes you make. So if you do fewer multiplications, you have fewer chances of making errors. So that's one good reason to do this. I'm being slightly facetious, but only slightly when I say the fewer things you do, the fewer mistakes you make. Basically, you don't want to do a whole lot of operations, though. But now think about what this means in terms of a computer, because you will be using computers in the future to do these kind of problems, especially this problem, where your counter is going from 16 to 924. Okay, before the constant is factored out, in this case right up here, I had 3 additions and 4 multiplications. After the constant is factored out, I still have the 3 additions, but I only have 1 multiplication. So in computing, you're going to save time and money by doing fewer operations, as well as an accuracy problem comes up sometimes. Let's look at this to impress upon you the importance of it. Let's say that counter was going from 1 up to 6 million. Now if the counter is going from 1 to 6 million, we'll have 6 million minus 1 additions. But if we don't factor out the constant, we will have 6 million multiplications. If we factor out, we only have 1. So you see how this makes a big difference when your counters, when you have a wide range for your counters. Here's a second rule for those that applies to the sigma notation. And at first it doesn't seem like it'd be a big deal. The big thing is it can help you factor out constants. But this rule is that when the formula contains terms that are added or subtracted together, you can break the sum at the addition or subtraction. And this example right here just shows you how that works. Now the counter is going from 1 to 3, so have k equal 1, write your formula out for k equal 1 right here, that's your first term. Advance the counter to 2, and here's your second term. Advance the counter to 3, and here's your third term. Now this is just arithmetic. At this point you can group these. You group the 1, 2, 3 together, and the 1 squared, 2 squared, and 3 squared together. That gives you 2 sums, and it gets written as shown right here. You don't have to do the intervening step. That was just to show you how to do it. The idea is that if you have a formula with a plus or minus sign, you can break it out into separate sums. And now we can combine these two rules. Here's our formula right here. We can break at the plus sign and create 2 formulas. Oops, no, I forgot there was one more term here. That minus, I want to show that. Okay, so we break at the plus and minus signs. That gives us 3 separate sums. Now in each of these sums we can then pull a constant out if we can. Now the first one, the 2 can come out in front. In the second one, the 3 can come out in front. In this one, there is nothing to come out in front. Well, you could think of -1 came out in front. Right? You can't factor these 2, 3, or the -1 here because the constant isn't multiplying everything. That's the only time you can pull the constant out in front. Now we have one more rule with the sigma notation. What happens if there is no, here's what we're used to. We're used to something like this. K equals, say, 3 to 7 of 8 to the k. In other words, we're used to seeing a k in the formula. What happens if there's no k? Well, you do the same thing, only there would just nothing to increment in the formula. So this is what would happen if the k isn't here. The counter is 3, so we have 8. Now advance the counter to 4. Well, there's just 8, nothing to do with the counter, but you keep adding. Advance the counter to 5, 6, and 7, and then you stop. Well, actually you have 5 times 8 is what you end up with. So even if there's no k in the formula, you still apply the rule. Create a first term, increment the counter and add, increment the counter and add, increment the counter and add, like that. Of course, there's a shortcut for this. Why do you have to add up all these 8s? If you could figure out how many 8s you're going to have, then you can just multiply by that. In this case, 5. Where did the 8 come from, or the 5 came from? You took the maximum number. If you take the maximum number and subtract the minimum number and add 1 to it, you will get the 8. 4 minus 3 is, the 5. 7 minus 3 is 4 plus 1 is 5. And here's the general rule. You take the maximum value of your counter, you subtract from it the minimum value of your counter, and then add 1. The reason for that is if you just subtract the max from the min, you won't be including one of the endpoints. You won't be including the maximum endpoint. You'll just be starting with the minimum and going right up to, but not including the max. That's why you have to add 1 so that you get all the numbers. So that's the rule for the constant. I'll just give you an example here. So if I'm summing, say, 16 from 47 to 934. I certainly don't want to work all that out. The rule is take the 934, subtract the 47 from it, add 1, and then multiply that number times the 16, and that's your answer.